Hello guys, you're welcome. We are continuing with our consideration of measurements in units. We are looking at how mass is measured. First off, what is mass? Mass is defined as the amount of substance in an object. The SI unit for mass is kilogram. The greater the mass of an object, the greater its resistance to the change in motion, a property referred to as inertia. Mass is measured using either a top hand balance or a beam balance. A beam balance is a very old instrument used for measuring mass. It will take some time to examine how it works. A top hand balance is a modern instrument used in measuring mass, and how it works is it detects the Earth's gravitational pull on an object, but then the reading is given in units of mass. So if you look at the diagram, you can see that it has a digital reading on the instrument, and the unit there is in gram. So although the object observes or detects the Earth's gravitational pull on an object, the unit that is given is in units of mass. What about the beam balance? Was it used to measure the mass of an object? It is a balance. So for the mass of an object to be measured, this balance that we have here shouldn't be tilted to one side. What would be on the two sides of the balance should level up, so that we know that the mass on one side is equal to the mass on the other side. So assuming we want to measure the mass of this object in the left balance, standard known masses are put on the right. Once they are put on the right, if the mass or the standard known mass is lesser than the mass of the object we are measuring, the beam balance is going to tilt to the left. We then have to add other masses to this until the two level up. When the two level up, what that will mean is that the sum of the masses on the right will be equal to the mass that is unknown. And so to find the mass of the unknown object, we add all the standard known masses on the right. The sum of those will give us the mass of the unknown object. So it is quite straightforward. We have to get the two sides of the balance to level up. So when the unknown mass is put in one pan, we put standard known masses in the other until the two are balanced. The sum of the known masses will give us the mass of the unknown object. So this is basically what you have to keep in mind when it comes to measuring mass. Let's look at how we can measure time briefly. The unit for time is second. The symbol is small s. Time intervals can be measured using a stopwatch. And a stopwatch is usually a handheld timepiece that is designed to measure the time between when it is activated or started and when it is stopped. It could be analog or digital. We use a lot of digital stopwatches now. But what you see here is an analog stopwatch. So we activate it or press a button at the top. For an analog watch or stopwatch, we have a needle running across the surface of the watch. So once it is activated, we have it move from one point to the other until we deactivate or stop it. Then we can read our time. For a digital stopwatch, it works in the same way. It is activated once a button is pressed, normally a start button, and deactivated when a stop button is is pressed. There's usually going to be a delay in stopping the watch. And we can curtail that if we do a number of repeated measurements to find the average of these values to be able to come up with how long it took for us to start and stop the watch. Talking about repeating experiments to ensure that we get an accurate reading, let us briefly talk about the simple pendulum. The simple pendulum consists of a string and a small mass. Usually we'll have the string and mass lying vertically or resting vertically. The time for one complete cycle, a left swing and a right swing, is called a period. From our diagram, we see what a complete oscillation is. The pendulum is moved to the right, comes back, moves through its equilibrium position or the vertical position, goes to the left, and then comes back to where it was initially resting. So as seen in the diagram, movement to the right, backwards, and back to the initial rest position gives us one complete oscillation. And the time it takes for one complete oscillation is referred to as the period. How then do we find the period or the time it takes for one complete swing or one complete oscillation of the pendulum? We use a stopwatch to time it. But then to ensure accuracy of our measurement of how long a period is, usually we undergo a number of repetitions of these experiments. So we take about 20 oscillations and time them together. Then we can divide to find the period or the time for one complete oscillation. For example, if 20 swings takes 50 seconds, then the period or the time for one oscillation, which is the period, would be found by dividing 50 seconds by 20. And that will give us 2.5 seconds. In your practical exam or even in the exam, sometimes you'll be asked to find period of an oscillation. If you have the time for a number of oscillations, divide the total time by the number of oscillations to get a period or the time for one complete oscillation. Thank you very much for watching. See you in the next video. Please don't forget to subscribe or to like the video.